right, worksheet 1 of Unit 8, our last unit, quadratic equations. So we've been talking about quadratics, and in the quadratics we've been talking, just to remind you of the definition, quadratic is one that has an x squared in it. Right? Not an x cubed, not a larger one, not an x to the 3 or an x to the 4, but it does have to have an x squared in it. And they form the shape of a parabola, which is this shape, this U-type shape, facing up or facing down. Okay? Now, to solve a quadratic, this is different than when we solve linear equations. So, in a linear equation, we just have to get x by itself, and then we have the answer. So that's nice and simple. But in a quadratic, it's a little more complicated. We're going to lead you to how to do this by hand, but first I'm just going to show you how you would do it on the calculator from the graph or from the table, right? Just to make sure that you can solve them that way. So now on a quadratic, what we're going to usually end up doing is we're going to usually end up solving when y is 0. So the solution is, when does x squared minus 9 equal 0? We call these places the zeros, and they're also the solution when we're setting it equal to 0, which is what we're normally going to do. Although you'll see later we don't always have to do that. Okay, so in this case, if I was to put this into the calculator, and I'll go ahead and do it, even though I already have the graph there, just to show you, I'd put this into y equals, and I would go x squared minus 9, and then I'm going to put the other side of the equation, which in this case is 0. Like I said, later on it won't necessarily always be 0, but we're going to use that for now. And we go to the graph. Okay? So now we see this graph. And it only looks slightly differently because the scale is a little bit different. But you can see where the parabola crosses the x-axis. These are what we call the zeros, and they are the solution. So when x is equal to 1, 2, 3, negative 3, when x is equal to negative 3, and when x is equal to 3, or negative 3, and x is equal to 3, then these are the zeros, or the solutions to this quadratic equation. Okay? So let's take a look at the next one. So I won't put it in the calculator this time, but you would put x squared plus 9x plus 14 in y1, and then you would put 0, because we're going to solve these by finding the 0 when y is equal to 0. So you'd put 0 here. And it would draw the graph, and you can see exactly where they cross. So it's at 1, 2, x is equal to negative 2, and x is equal to 3, 4, 5, 6, 7, x is equal to negative 7. Alright, I'll leave the last one on that row for you to do, but you're just looking for where does it cross the x-axis. And that would be the solution for when this is equal to 0. Alright, in the table, very similar. So this one, we saw this in the graph. So now we're going to look in our table. Now, this table only has these two columns because we don't really need this column at the moment, although we will later. So just looking at this column, so the solutions are when y is equal to 0. So one of the solutions on this one back here would have been when x is equal to 3, and then we already know that answer, x is equal to negative 3, y is also 0. So if we take a look at this one, we look at this table, and we're looking for when y is equal to 0. So in this one, when y is equal to 0, x is equal to 2. Now this is a good point. If I look on my calculator here and I put this formula in, x squared minus 4x. If you remember from Unit 6, we said that a parabola can have one solution when it just touches the x-axis. It can have two solutions, like the ones up here, where it crosses twice, or it could be one like this, where it doesn't touch it at all, and it would have no solutions. Okay, so if we take a look at this one, we're looking for when y is equal to 0. So the answers would be x equals -1 and x equals 4. And again, on this one, we're looking for where y is 0, and then the x answers would be over there on the side. So I'm not going to write that down. Just for those of us who are just watching and not listening, they won't get that answer. All right? So now if we're going to do this, just in the calculator, I'm going to work a couple of these and do this first one here. So go back into my y equals and delete, plus 1x, or just plus x, minus 20. All right, and then I'm going to put the equals 0, because what we do here is we're setting this up when it equals to 0, unless, like this one, we have something else there. And I'll show you what to do with that in just a second. So here we go to our graph, and we can look on our graph and see that our solutions are at 1, 2, 3, 4, 5, -5, x is equal to -5, and 1, 2, 3, 4, x is equal to 4. Okay, and if we go on our table, we can find those same values by finding when y is equal to 0. So at -5 and at 4. Okay, now just a little point. All the ones that I'm going to do on this page come out evenly. If they don't come out evenly, there's something else you need to do, which I'll show you later on when that comes up. Okay, but there is a way to do it from the graph to be able to tell exactly where those values are. And we'll do that a little later on. All right, so number 9. So we go x squared minus 9x plus 14. And we graph. And we can see that our zeros are at 1, 2. Our solutions are x equals 2 and x equals 3, 4, 5, 6, 7. X equals 7. And it's a good idea to get into the habit of looking in the table and making sure that it's exactly at those points and not at a decimal near it. So at 2 and at 7, y is equal to 0. All right, so now on number 11, what we normally do, and what we're going to have to do when we're solving these by hand, is we want to get this equal to 0. So what we're going to do is we're going to add 30 to both sides of the equation. Okay, so now this is equal to 0, and we can just plug that in. All right, and we'll get our answers that way. I did want to show you, though, that we can do this one without doing that step if we're using the calculator. Later on, when we do it by hand, we're going to have to do it. We're going to have to do that step. But if we're doing it on the calculator, I want to show you what happens. If we put this one into the calculator, we have x squared plus 13x. Now we can do the plus 30 over here and equal to 0, and that would give us the same answer. Or we can just go ahead and put the minus 30. Because remember, I've said all year long, you can solve any equation. Put one side in y1, put the other side of the equation in y2, and it's going to give you the solution. So if I go into my table, I'm going to look for where both y1 and y2 are the same. So I'm going to look for where they're -30. So there's one of them. So at -3 is one of our answers. y is equal to negative 3. And the other one should be at negative 10. There it is. So those are both the same at negative 10. Okay, so just to show you, if we had done it the other way, it would have worked out the same. I'd done the plus 30 that I talked about, and just set this equal to 0, and go on my table. It's still, they're both 0 at negative 10, and they're both 0 at negative 3. So that gives you the same answer. So I'm going to leave the other three for you to do.